So today I'm going to talk about the Morpho approach more specifically, and how we explore the trade-off between monolithic and modular, and the solution we've thought of while building Morpho Blue, and the vision behind it. So maybe very quickly about Morpho, for those who don't know about it. So we're a lending and borrowing protocol. We started 2 years ago with an optimization layer built on top of Aave and Compound. And then we were like probably one of the biggest users there of Aave and Compound. And we decided to build our own lending and borrowing protocol because of we were missing some features or some resilience that we were expecting as builders on top of lending and borrowing protocols. And so we ended up building what we call now Morpho Blue, which is a completely immutable and permissionless protocol, lending primitive. You can think of it more as Uniswap for lending. And this talk is going to be about the monolithic versus modular approach in lending. So there is especially recently, a lot of debates around how do you design a lending and borrowing protocol. Should you make it a monolith or multiple pieces that sort of compose with one another? And the first approach is the monolith approach. So essentially, that's the Aave and Compound model. So first introduced by Compound, and then Aave iterated on it a lot and improved it up to the V4 version that was introduced very recently. And really, what's great about this approach is that it gives you a very nice financial product, right? It's super easy to use. You have very deep liquidity because all assets are put together in a single pool of liquidity. I think you have protocols like Instadapp that call it the unified liquidity layer. I think Aave V4 has a similar term. And by treating all assets in this common pot, you have deep liquidity. So large borrowers can come in at any time and borrow large amounts of money. Large lenders, they can withdraw at any time large amounts of money. And also it gives great stability in interest rates as well. And so it's really about having this full stack experience where you put all the features and all the management, and you sort of hide this away from the user. And so the drawbacks of this approach is that it's really a one-size-fits-all approach, right? When you deposit some USDC on a given instance, you get exposure to all the different collateral backing at the same time. And oftentimes, because you have a lot of features and you have to have the logic of the code that put all those assets together, it means a lot of lines of code, and upgradable patterns are needed, and that often turns into incidents. Because due to upgrades, or just because the code is extremely large and insanely complex. I do encourage people to look into the number of incidents and reports that you have in Unify and lending protocols, whether at the pool level or at protocols built on top of lending pools. Because lending pools upgrade, they're changing specific lines of code that could impact integrations that are built on top, right? And the last thing is really the fact that those instances, and this is what we discussed during the panel, are governed, right? So they're governed by token orders. So we mentioned the upgradability pattern, but also the risk management part. And really the idea is that token orders are going to decide on hundreds, literally hundreds of risk parameters that are fairly complex to understand, to be frank. You have, for example, what's the Oracle pricing a given market, or what's the collateralization ratio that you allow on a specific asset up to what cap, each for those parameters for each asset. You have maybe 10, 20 different assets in each pool. Then you have multiple pools on different chains. So that's a lot of parameters. They're all interdependent with one another, with the market conditions and with the parameters of other lending protocols. And we're assuming that token orders are both knowledgeable and active enough in order to make those decisions. And in practice, of course, they're not, right? Anyone can buy a token. You don't have a PhD in risk management, right? And you don't have to be super active. So obviously, you're going to delegate this responsibility to a consultant, right? To a risk manager that's going to, essentially do the hard work for you, right? But the problem with this approach is that it's some kind of exclusive contract behind the funds of the lending pool and the risk manager that essentially gets paid as a consultant in order to perform those risk management, right? And also there is low incentive for open sourcing. Like when you have like some risk management tooling that you're operating as a consultant, well, if you open source your models and if you open source the code you use to set those risk parameters in Aave or in Compound, well, then you have very little pricing power when it comes to negotiating terms for your contracts, right? So you have really incentives in making this open. So the TLDR is like right now, most of the computation in landing pools of risk parameters are oftentimes completely closed source, right? And decided by token holders even though, and green-lighted by token holders, but closed source, right? And so it's very clear that there is a better need for in the space for like more robustness and more flexibility at the same time in the things we want to do. We could argue also more efficiency, but really the two main things are like security and flexibility. And so modularity emerged as a solution to this trade-off, right? As a solution to those problems. So the idea of like modular platforms in general is that you can create your own landing platform and configure it the way you want. With anyone can become manager and essentially provide a unique risk profiles to users given their appetite, right? And that's really interesting because essentially the idea is that you can essentially fit the risk profile of pretty much anybody, right? Like you can create a landing pool, a fork of Aave, for example, or Compound that is specifically designed to answer a specific use case, right? And this is what Maker did with Spark, for example. Like they had some specific needs, and so decided to fork the Aave v3 implementation in order to be able to answer those needs, right? And even though that's a great approach, it has some downsides as well. Like as soon as you start creating two different instances, you fragment liquidity, right? And even though you can sort of like mitigate that through composability, like for example, if you take Compound, Aave, Spark, they have a lot of like collateral in common. And they have a lot of collateral in common, but they don't share liquidity with one another, right? And each instance is going to fragment liquidity even further, right? The second thing is that you have a lot of different it's harder as a user to make your choice, right? When there is just Aave, then okay, it's fine. You trust Aave, you just deposit in Aave. If you have multiple options, and we were discussing this during the panel, well, you have to make your own decision, which complexifies the user experience. And the last thing is that modular platforms in themselves are frankly just a code library at the end of the day, right? It's just like you have a piece of code and anyone can deploy it, right, and build their own landing protocol. The same way people used to fork the Aave v3 or the Compound v2, not Compound v3, but Compound v2 instance. The code in itself does not create value. What creates value is, as we were discussing, the state and the management of it, right? So the new use case that we create by forking the Compound instance or the Aave instance will generate value because there is some liquidity, so we match lenders with borrowers, but also because we do proper risk management. Right. So in one case we have the Monolithic approach, which has the nice aggregation of all the liquidity, and I think if you haven't looked into it, the Aave v4 forum post explained how they're essentially taking this even further and aggregating liquidity like no other like modular approach would today. And the modular approach does not they aggregate liquidity, but they're quite restrictive in what they can enable. And on the other hand, you have modular platforms that are very flexible. They let you create what you want, but then they fragment the state. They fragment the liquidity, etc. And this is where the concept of aggregation comes in. And I think it was a term that was first used in the context of a Polygon blockchain stack, where essentially you have the same, in the infrastructure side, the same trade-offs between monolithic and modular, and they came up with the term aggregation, which essentially is visualized this way, which is you have multiple instances, in some kind of modular paradigm, but they share liquidity to some extent, right? And so the idea is that this aggregation at the liquidity level, like the goal is really to be able to have the flexibility of modularity while preserving like a common state to a certain extent. Right, so how do we build such thing, right? What does it mean, in practice to have like aggregation and shared liquidity, et cetera? Well, what you need in the first place is a flexible primitive, like core markets that are minimal enough and opinionated enough in such a way that they can be shared by multiple people, the multiple builders on top that want to express different risk profiles, right? And then on top of that, you have modular layers. So the core primitive in itself is not modular. It's flexible in such a way that you have multiple users coming to it, but the modularity comes on top, where you can essentially rebuild and abstract away all the complexity of having a primitive. So like the UX, the reaggregation of liquidity, the risk management, et cetera, et cetera. And the idea is that they are completely optional. You don't have to inherit from the entire code base, for example, of using a very large protocol that does at the same time UX, risk management, account abstraction, et cetera. You just take the risk of what you're essentially taking. Like if you want account abstraction, then you take the risk of like the tech behind it. But if you don't want it, you don't have to subscribe to it. Right, and so this is essentially with this philosophy that we built like MorphoBlue, which is we want something that's sufficiently primitive such that it can be recomposed into multiple modular instances that will share eventually those mini Lego bricks, elemental Lego bricks, right? So one market on MorphoBlue is really one collateral asset, one loan asset, one liquidation loan to value, and one oracle. It's as simple as this, and it's immutable forever. And some people like to qualify Morpho as modular, but I disagree that the primitive in itself isn't modular on purpose. It's actually very primitive and in such a way that it's generated in such a way that multiple users will be able to reaggregate on top. So that's MorphoBlue. The downside with this approach is obviously that as we were describing earlier, as a lender, you have to do your own risk management, right? You have to decide, OK, should I be lending to so I have some USDC. Should I be lending it to the pool backed by STEs? Should I be lending it to the pool backed by WBTC? With what oracle? Up to what, loan to value? All these kind of things, right? And so this is why we have a second layer, which is the risk management layer that we like to call Metamorpho, where essentially, you have risk experts that can build their own risk managed vault and provide this passive experience to users. So if you have USDC, well, you can go into the Block Analytica and RiskDAO vault, or you can go into the Gauntlet vault. Gauntlet, which by the way was initially a consultant for Aave and transitioned to this new model of providing service to users directly. And so you go to their vault, you provide liquidity, and they're going to do the risk management on your behalf, essentially. And this way, you have multiple vaults, expressing different risk profiles. Some of them will expose you to real-world assets, to blue chips like STEs, WBTC, et cetera. And the idea is that those different vaults, well, they can share some markets, right? They have some markets in common. So for example, in the chart here, you have market 2, which, for example, could be like WSTEs to borrow USDC, right? If 2 vaults of USDC list this market, they would share liquidity. So to recap, if you have Compound and Aave, they both list STEs, they don't share liquidity. If you have 2 Metamorpho vaults replicating similar risk profiles as Aave and Compound, they will share liquidity to the extent that they share risk. Anyway, so that's a quick recap of the approach that you have on one side and on the other side, where essentially the recap is that we break into 2 pieces, the risk management and the liquidity and interest accounting part, such that the risk management is modularized, and anyone can plug into those elemental bricks that share liquidity and aggregate liquidity. OK, so this is what the stack looks like in practice. You have different risk profiles, with some for example, Steakhouse Vault has a bunch of real-world assets. Some people don't want exposure to this. The Block Analytica Vault is extremely blue chip around assets like STEs, WBTC, SDAI, et cetera. RE7 is more oriented around LRTs. And sometimes all of those markets, they do share some markets. So, for example, the WST Swiss market is shared by a bunch of those different risk curators. And so they will share liquidity to the extent that they share risk. And so, at scale, this is sort of like what the stack looks like. I just presented Metamorpho, but there are many layers of abstraction that you can rebuild that either reaggregate liquidity, that arbitrage rates, reaggregate liquidity for lenders, but also for borrowers to get like a very similar experience to what you have on a Aave or a Compound. And again, as a user, you don't have to subscribe to all of this. You only subscribe and you only pay for what you need, essentially. And obviously, the advantages of that is that we have like a very immutable and robust core, which is frankly something we, as builders on top of Aave and Compound for the last 2 years, we wish we had integrated. And finally, the obvious upside of all this is that network effects compound, right? Like the more builders we have around the stack, the more liquidity and the more efficiency you get into this free market model, essentially. And so the more liquid and more efficient everything becomes. So yeah, that's it. I don't know if you have any questions.
All right, so OK, we have the first question right here.
Hello. The Metamorpho number of where you've offloaded risk management, or it's outsourced, or however you want to describe it, extrapolated away. And as you mentioned, some of the people doing risk management now for you are former, and maybe even current, I don't know, working with Aave. So there's obviously overlap there in expertise. But I'm curious, is the risk there that over time we're going to see consolidation at that layer? So now where you have lots of different people doing different things, and you can choose, but the reality just might be that in 3 years, 5 years, I don't know, Gauntlet or Steakhouse, and they're doing 90% of the risk management. And you're kind of back where we are, if you will, today with one large entity kind of controlling your risk management.
Right, so I think that's a great question. So the first thing I would say is that it's very unlikely that the risk profiles of the entire humans, human beings, all comes back to one risk profile, right? So it's pretty much sure that we, as humans, we have different, risk appetites, and that we want to expose ourselves to different risks, right? Then we could make the point that, maybe, I don't know, like RiskDAO or Block Analytica are going to spin off, 5 different vaults, and each vault is going to cater a specific risk profile. But in practice, some of those vaults require like a bunch of expertise on specific assets. Like if you take real-world assets, for example, like Steakhouse has like a deep expertise on those things, right? RE7 is more deep into LRTs and those kinds of things. So I think right now we're biased in the sense that DeFi is merely a couple, merely $100 billion, but the over-collateralized lending market in TradFi is $1 trillion of volume daily, and they all have very different risk profiles, right? So eventually, you could imagine a world where you can extend this to eventually, credit underwriting as well, right? Like where essentially Metamorpho vaults can do algorithmic risk management, but also, essentially become credit funds, right? And so our take is that yes, in the current state of DeFi, which is frankly quite small, it is possible to fungibilize everything into one mega pool, right? That we all trust, and that will cover 50% of the market, which is approximately what Aave has right now. But as DeFi scales, I'm having a hard time believing that all humans are going to be treated equally in one pool. And also the second thing is that it's a free market, right? So it's completely permissionless, it's completely open. So if one player starts to become very big, then you can challenge this player, either by lowering the fees or by going for like more risky things or like innovative ways. I think open source has been like a great differentiator among it's been very interesting, frankly, to see like all the different risk creators competing with one another. One of the differentiator, of course, is the fee, but the other one is open source, right? Like how do you open source your LTV formula or this kind of things. Anyway, I hope it answers the question.
All right, thank you. So yeah, please thank our speaker.